Hi there. We posted a video last week on some of the on exam predictions and some of the questions we thought might come up, and a lot of people were requesting could we go through some of the mandatory experiments that I mentioned in that video. So I thought I'd do a quick series of videos going through some of the mandatory experiments that I feel are most likely to come up this year. So we'll start with question 1 then, and as you can see here we have by titration in mandatory experiment 7.3 to determine the concentration of ethanoic acid in vinegar. So first of all, there's often some general questions related to vinegar in questions like this. So if we take a look at some of these details, generally a solution of vinegar is for 4 to 8% volume per volume. So keep an eye on this kind of thing, these kind of measures of concentration. Percent volume per volume is, whenever you see a percentage, it's going to be per 100 centimeters cubed. So if it's volume per volume, then it's going to be a certain volume of liquid per 100 centimeters cubed of solution. So, for example, a 6% solution of vinegar will mean that there's 6 centimeters cubed of pure ethanoic acid in 100 centimeters cubed of vinegar solution. Here we have the structure of ethanoic acid. And note that this is the hydrogen that's donated. Just remember that. You'll know this from organic chemistry. And speaking of organic chemistry, it's a nice place to incorporate some of those questions related to carboxylic acids into that. And it has been asked before, often in relation to the oxidation of ethanol to produce ethanoic acid. Let me just jump out of here quickly if I can. And I'll just go to those notes. Having trouble here doing this. Sorry about that. So if we look at this, here you can see that these are notes from organic chemistry and related to carboxylic acids. So again, there's a question previously, I can't remember which year, but it was about wine being oxidized by air. A bottle of wine's left over, and then you get that sour smell of wine, that smell of vinegar in the wine. So where has it come from? Well, it's come from the oxidation of the ethanol. This equation here shows methanol, of course, but the same would be true of ethanol. Ethanol will go to ethanal and then on to ethanoic acid being oxidized by the oxygen in the air. So this is more related to using sodium dichromate and potassium permanganate. Another thing to keep an eye on is the stability of the carboxyl ion. It doesn't get asked very often, but it would be a nice place to ask it if they wanted to ask a more difficult question in the ethanoic acid question. So this idea of why this hydrogen is donated, okay? So it's because of this inductive effect where the high electronegativity value of the oxygen is pulling electrons around here, and you get a general movement of electrons through this functional group, weakening this bond here because the electrons are pulled further towards the oxygen. So this can dissociate then as a hydrogen ion. So those kind of questions could come up possibly there. What else do we have? So generally about titrations then. So we know we have strong acids and weak acids, strong bases and weak bases. So this gives us 4 possible titrations, as you can see here with the different types of pH curves we have. Now here, ethanoic acid is a weak acid, like all carboxylic acids and generally all organic acids. So here we know that it's going to be sodium hydroxide. So it's going to be a weak acid against a strong base, okay? So here it's going to be this one. So we're going to be using phenolphthalein, okay? Because that's the only real indicator that we have that aligns with the straight portion of the pH curve for a weak acid, strong base. Okay, so phenolphthalein will be the indicator we use. And once do stay aware that that's the reason why, because it corresponds with the straight portion of the pH curve. To arrive at this, you probably have done this when you did the experiment. You probably would have done a series of titrations. So I know the previous experiment was to standardize hydrochloric acid, but generally you need to start by making up a primary standard, and that primary standard is generally sodium carbonate. We can then use that primary standard to standardize hydrochloric acid, which will make that a secondary standard. That then can be used to standardize our sodium hydroxide solution, which we are using to standardize the ethanoic acid in this experiment. So that's where our standardized sodium hydroxide is coming from, because it itself, of course, is not a primary standard. So it needs to be standardized in some way. So this sequence of titrations is probably something that you did, or at least your teacher did, in preparing the sodium hydroxide for this experiment. Yeah. So do be aware of that sequence of steps. There's been a question. Main thing, of course, I forgot to say was, why do we have to do that? Why can't we titrate the ethanoic acid against the sodium carbonate? Well, because of course they're both weak. Sodium carbonate is a weak base. Ethanoic acid is a weak acid. So, I mean, that would have been ideal since we can make this up as a primary standard. So just use that base to directly standardize our ethanoic acid in the vinegar. But of course we can't do it because if you look at the pH curve for weak acid, weak base, there is no real significant straight portion to the curve. So there's no indicator that we can use to indicate the endpoint. So for that reason, we've got to go through all this rigmarole of going through these series of titrations. Okay, that brings us on to the actual experiment itself. So there's quite a few details here. First of all, we'll start with the dilution of the vinegar, okay? Like we said above, most vinegars are about 4 to 8%. That's relatively concentrated here. You can see this one is 6%. Now, the problem is we will always, and there'll be definitely a question on this if there is a question on ethanoic acid, they always ask about the dilution, and they might ask you to outline the steps for dilution. Also features in the bleach titration, this dilution of some of our original solutions, and then we'll factor in that dilution factor later on when we're doing the calculation at the end. So here, what are we doing? Well, why are we doing it first? Well, because the vinegar is so concentrated. If we use the vinegar straight, as in we just took this and put it straight into our burette, the problem with that is we'd need a very concentrated solution of sodium hydroxide. Otherwise, when we add the vinegar, it's simply going to give us a very, very small titer of maybe 0.1, 0.2, 0.3. If it's much more concentrated than the sodium hydroxide. So if we use 0.1 molar sodium hydroxide against 6% vinegar, then we're going to have a very, very small titer. And a very small titer is just inaccurate, okay? So what are your other options? Well, you could use a more concentrated solution of sodium hydroxide, but then you're just wasting chemicals. So it's a much simpler thing to just dilute the vinegar. The most common dilution factor is 10. Okay, so we would maybe take a 25 centimeters cube pipette, and then we would, well, of course, before we do anything, we'll have to wash the pipette. So we'll first wash it with deionized water, and then the solution it's going to contain, which of course is our vinegar. Then we'll pipette 25 centimeters cubed of that into the volumetric flask, and then we'll use a wash bottle to bring the volume up with deionized water very close to the mark, and then we'll use a dropper to actually bring it to the mark, the bottom of the meniscus, and so on. Okay, and then you'll turn it upside down 10 to 20 times to make sure it's homogeneous and so on. Okay, so this dilution of the vinegar is a very important part of this experiment. Okay, so what have we got then? Well, you'll be given a known concentration of sodium hydroxide. Here it's 0.1 molar. And we will take 25 centimeters cubed of that, again, washing the pipette with deionized water and then this solution before we transfer it. That goes into our conical flask. We'll add a couple of drops of our indicator, as we said, phenolphthalein. It will be pink initially in the base, and then it will change to colorless at our endpoint. It'll change quite sharply, of course. Be aware, phenolphthalein, like all these indicators, are weak acids. So you only add 2 to 3 drops, because if you add more than that, it will actually affect the titration. Okay? So that will be the details for our sodium hydroxide, which will allow us to find the number of moles of sodium hydroxide. And for our ethanoic acid, then we'll go through the procedure of our rough titration. Here we had 22.9, let's say, and then we have 2 titers of 22.6, 22.7. So within 0.1 centimeters cubed of each other, which allows us to finish up saying that we can get an average of those two. And that's our average titer, 22.65 centimeters cubed. Okay. Right, and that will give us our average titer here. Sorry, that's a little error there, that should say 22.65, not 9.1. Apologies. Okay, so the main steps here are, of course, we don't need to worry about those. They're the general steps for any procedure, except for the last thing. When we'll get the moles of the base, will give us the moles of acid, and then we'll go through these steps. But we'll see that in the question now. Okay, so let's take a look at that question. I can't remember what year this is from, but it's one of the past papers. We'll see in a second. So we're told that 25 centimeters cubed is diluted to 250. So that's going to be a 1 in 10 dilution. Okay, how would you know that? Well, you can simply divide 25 into 250 and you get 10. So it's a 1 in 10 dilution. So the solution we're doing our titration with is 10 times more dilute than the original vinegar solution. Okay, that's going to be titrated against 25 centimeters cubed of 0.1 molar sodium hydroxide. And as we said, our average titer was 22.65 centimeters cubed. We're asked to find the concentration of the ethanoic acid in moles per liter, grams per liter, and percent weight per volume. Okay, so we have enough details for our sodium hydroxide to find the moles. So the moles are going to be the volume, 2025, times the molarity, 0.1 over 1,000, and that gives us 0.0025 moles of sodium hydroxide. So that's the number of moles of sodium hydroxide that was in our conical flask. Just go back up so you can see. So that's what was in here, number of moles of sodium hydroxide. Then we have, we know we have 22.65 moles of centimeters cubed of ethanoic acid. So we want to find the molarity of that solution. Now, of course, we'll be given the equation. So it's a ratio of 1:1. So for every mole of sodium hydroxide, it will react with 1 mole of ethanoic acid. So I will have the same number of moles of ethanoic acid. Okay, so I can reverse this equation here to find the molarity. So it's going to be 1,000 times the mole over the volume. So it's 1,000 times 0.0025 divided by the average titer, and we get a concentration of 0.11 molar. Okay, now this is my diluted solution. Okay, so the next step will be to actually find the concentration of the original solution, because that's what we're asked. Okay, we want in the vinegar, the ethanoic acid in the vinegar in moles per liter. Okay, so this is moles per liter, but it's moles per liter of the diluted solution. Okay, so here we're going from the titrated solution back to the original vinegar solution, so we're going to multiply by 10. Okay, and that gives us 1.1 moles per liter. Okay, or 1.1 molar. Okay, we're also asked to find the concentration in grams per liter. So to go from moles per liter to grams per liter, all we're changing is the what's above the line. So moles is going to grams, the liters is staying the same. So all I have to do is multiply by the molecular mass, which for vinegar is 60 grams per mole, and that will give me 66 grams per liter. Okay, and then the last one they want is percent weight per volume. Okay, so again, whenever we see a percentage, it's something per 100 centimeters cubed of solution. Okay, so it's weight here, so it's going to be grams. So it's the number of grams per 100 centimeters cubed. Now here we have the grams per liter, which of course is 1,000 centimeters cubed. So what mass would I have in 1/10 of the volume? Well, I will have 1/10 of the mass if it's going to be the same concentration. So I'll simply divide this by 10 to go from grams per liter to percent weight per volume, or grams per 100 centimeters cubed. Okay, so divide by 10, that gives me 6.6% weight per volume. Okay, they're the main points that you need to look out for. I'm trying to remember, if you want to go back and take a look at some years, you could, just jump into the website. The video, of course, will have a lot more details. If you need anything, take a look at that. We can see here vinegar came up in 2016 and 2008. So you can take a look at those questions. So you can see there's been a stretch of a few years here, and it's kind of coming up relatively regularly. So maybe it'll come up again. It's a relatively nice question. I believe actually, you'd have to go and check this, but I think it came up in 2002 as well. And that paper is available online. If you go to the government website, you'll be able to download it. I'm pretty sure it's there also. Okay. All right. Hope you find that useful, and stay tuned for another one. I'll try and do another one tomorrow. Okay. Thank you.